All right. Okay, thank you all for coming out here. This talk titled 1.21 GigaWatts is about hacking solar panel controllers. I've given this talk at RSA and DEF CON, but they're like a 25-minute version. And when I present it for SAINTCON, they're like, oh yeah, let's do that, but make it like 60 minutes. So you guys get the more detailed information. I'm going to show you exactly. I have the solar panel up here, the controller up here, and I'm going to show you some of the attacks that I did on it. The firmware or attacks or the hardware attacks is part of this. And then I'll try to leave some time at the end for questions. But with that, I'll kind of get started. And forgive me, I'm going to be showing different screens that I usually don't, so I may have some tech issues, but hopefully they're not big issues that hold us back. So a little background on me. I do this kind of stuff for fun. In fact, this was my 2020 project. I was locked in my house for quite some time, right? I just also had a newborn, so I had a lot of time at home, but it was like sporadic. And around the same time that we all got locked at home, a little before that, my neighbor's like, oh, check out the new solar panel system I have in my house. I can control it via my phone. And I was like, oh, that sounds interesting. I think I got a new project. So my neighbor's house has solar panel controllers, and I have free time. That's what led to this project as it is. I'm going to tell you step by step what I did, how I go at this, what worked, what didn't work, kind of props to the company, and what doesn't prop, or where they failed. I also do IoT pen testing for work, so I can kind of say, this is a systemic issue, et cetera, as we go through things. So overall, when I get a hardware project, I always start online. I never touch the device to start with, right? Like when I first get the device, I want to find out, okay, what am I looking at? What's the attack surface before I start to break things and take it apart? That's the last step I want to do. So this is a slide taken from their marketing material. It talks about their whole in-phase setup here, right? You've got these solar panels on the roof, and each one has their own micro converter on it. I think. Does my mouse show up on your screen? Perfect. The little converter, they're really happy about their connector they use, so they highlight that in these slides for some reason. But you can control it via your iPad. The person who installs these things does it via his iPhone. There's this battery pack, and it's all, the brains of this operation is this in-phase Envoy controller. This is the brains that then talks to the cloud and reports your production and how much consumption you're doing, and then you talk to the cloud component with your phone or your mobile device. But what I found interesting is that the installer uses the phone on your site to configure the device. I was like, okay, there's an installer app. I got to go find that. So I go looking, on the Play Store or Apple. There's two apps out there. There's the app for the user, the end user, and there's also the installer toolkit app. Pulled them both down. I was like, oh, this is great. Let's go ahead and start looking around. I also scoured their site looking for firmware images. Didn't find anything on their site. So they didn't have the firmware images available to users to download and upload their devices. So that was kind of a win for them on their side. But their apps are out there. And so their apps, what their apps are, were actually the Android app and the Apple app. Both just were .NET covers, so like the JavaScript just called into a .NET library and the Swift code called into a .NET library, and the .NET library did all the heavy lifting. Let's see if I can get that screen up. Give me just a second to figure this out. All right, that's the screen I want, but I don't, oh, there we go. I get to see it there. Okay. And I'm going to open ILSpy. So ILSpy, ooh, that is tiny. ILSpy is a tool for viewing .NET assemblies. And so with ILSpy, I load it up in there, and it does pretty much a really good reversing. I can almost get the initial source code minus comments from them. And so I'm scouring over this source code looking for anything interesting. And one of the first things I find is a URL here. Can you guys see that? That's really tiny for me to read. I don't know if you guys, can you read this? Great. So there's a URL to a Amazon SW3 bucket, right? You can see that? That's where their firmware packages are at, is this SW3 bucket. But I didn't see any creds for that. So I'm like, okay, well, there's this bucket out there. Let's go look at it. Now I'm going to try to do something that's, again, not what I plan on. And we'll just skip to the desktop. desktop. Oh, I got to close that. That's rough. So, AWS, there's command line tools if you're familiar, AWS, and one of them is the S3 LS. And that's not going to work because I didn't tell it what I'm going to LS. But basically, all I need to do is just say, oh, I thought I saved this somewhere. Now I don't see it. Bugger. Bugger. Darn. Okay, well, that part of the live demo didn't work. But that link that I showed here is actually an open S3 bucket, which means if you just use, actually, why don't I quit being lazy and just copy that. That's so tiny for me, so I hope this will work. All right, I'm getting that so I can read it, and we'll try that. What did that say? Bucket name cannot be found. Oh, because I don't need the HTTPS in front of it. Okay, let's try that again. Oh, where did it go? I stopped running my but I'm still presenting. I'm still here. Do I need to have PowerPoint running for that to work? Oh, thank you. Okay, so here, we'll try this again. So here I just do an ls of the name of that bucket. All right, I'm going to move on. I'm not sure why that's not working. That should just work just fine. And I can get a list of what's on there on that bucket. Let's just skip ahead. So here is a screenshot of me doing that from before. I had the syntax wrong. Sorry, guys. But you can see the list of the packages that they have up there. The extensions on those are a little funky, though. That's like a .eepkg instead of just a sum or a TGZ file. And what it was is, so they have a public bucket where all their firmware images are, and there's also an XML file saying which images apply to which devices, which was really, really great for me as a researcher. But this anything with an eepkg was encrypted. In fact, they have on that site is also a Ruby script which goes through the install, and part of that Ruby script says, hey, grab these files and decrypt it with this eecrypt tool. Now, I scoured the web looking for this eecrypt tool, and it's something specific to them, and it's only on the firmware images. So now I've got this kind of catch-22 bug where I've got the firmware images, but to decrypt them, I need this tool which is on the firmware image, right? Like they kind of got me around a loop here. So I thought I had a win having full access to the firmware images, but it turns out I don't have them until I have that tool. So now I have a new goal, is somehow to find this tool. Also in the installer app, the .NET assemblies, they all reverse really easily, except for there's a spot where that installer app, let's see if I can switch screens again, will call into, and I'm going to step down here because that's too small. I can't see it anyways. There's a spot in here where it will call into a password a function. And that password function's emu get mobile password. And what that'll do is that'll call a native assembly, like an SO file, which will then calculate some kind of password in C code and then report it back up to the .NET. And as a reverser, whenever I see native code or .NET code or Java's code calling into some low-level assembly function, the real reason you would see that, or that's there, is to do like driver tasking, right? You're doing low-level stuff. But this doesn't do anything with low-level. And in fact, the other time we see it, which is not the real use for it, but we see it is people are trying to hide something. Like developers know, oh, .NET is easy to reverse. Java's easy to reverse. But if I write this in C and it compiles down to assembly, they won't figure me out. Me as a reverser, I'm like, dude, you're playing right into my trap. Like, I reverse assembly. I love that stuff, right? So when I see you go in there, it's basically like, look here, this is where the goods are, right? And so I grab that SO, I reverse it, and you can see that the two other screenshots here kind of show that function. It basically builds this string based on the username and in-phase energy in like every other case, and it builds an MD5 of that, and then it kind of does a CRC on that, and that's the installer man's password, right? So all I need to know is the serial number of the device, and I know the installer's password for that device now. It's like pre-computed via this tool. So I'm like, great, this is an easy win for me. Okay, so at this point, I have a password. I don't have access to the firmware images. That's as far as I was able to make it without actually touching the device. So now now it's time, let's get one of these and break it down. This is one I grabbed off of eBay. It's sitting right here. This box, that picture's better, so I'm going to show you that one before I jump to mine. So there's this line across here, and this line divides the high power side from the low power side. So this is all 110. And all these down here, this is for all your solar panels that are coming in to show how much consumption or production you're doing, and then these are for outbound things to tell how much consumption you're doing as well. So you wire this up in parallel with your home systems. Actually, if you dare say, Enphase is actually really popular here in Utah. Do any of you have solar panel systems and recognize oh, I have one of these? Anybody? I see at least a few hands out there. Yeah. We'll talk about this because this is still an outstanding bug. I've reported it to them, but they haven't done much about it. So this is the controller. That's the high power side. Over here on this side, this is a custom chip for tracking the power consumption. This is the main processor, which just runs a Linux kernel. This is the RAM for that main processor. It's got a battery backup, Ethernet port, USB, and then this is the Wi-Fi chip that goes with that. So this is the whole system. On the back side, there's a chip or two more, but they're really small. So yeah, let's say I want that screen over there so you can see it. Okay, so here's mine, that same chip, that same thing. For testing mine, I basically just took a power cable, just a regular outlet, and cut it and spliced it and plugged it in right there, which I'm sure is not like OSHA compliant or anything. There's just like 110 wires right there, kind of exposed. It is actually scary for me too when I plug it in. Sometimes I worry that they're going to touch, but not enough that I actually did anything about it. So that's the device. But on there were a few exposed debug pins that I noticed. Let's see if the camera's going to focus. No, it's not really focusing. But right here, I have some tweezers so I could point. So right here, you can see a set of jumpers. There's these really tiny 10-pin here. That's going to be the JTAG interface. And then there's 4 pins right here, and I found that those are a UART interface. So you've got like transmit, receive, ground, and power, right? So these are attack surfaces that I have to interface with it while it's running. But I'm getting ahead of myself. Before I talk about that, I want to talk about top-down. When we do pen testing against type of things, there's kind of an attack levels. There's different levels of the device and different attacks you can make at each one. So there's when the thing's first starting up, like the boot levels, until it's finally running. And I'm going to talk about these in reverse order because most people attack it. Yeah, we do our attacks from running and then work backwards if we have to. So the highest level is when the Linux kernels completely boot up, and the attacks that are possible here are pretty much your attacks against any Linux machine, except for this is just a slightly smaller. But if it's running telnet, if it's running HTTPS, if it's running SSH, we're going to enumerate those, see what software it's running. If there's known vulnerabilities, that's an easy win, and we don't have to work any harder. In this case, the SSH was running, telnet was not running, and there is a web service, but there wasn't any known vulnerabilities for anything that was out there. We can also try to connect to those 2 ports I showed you, the UART and the JTAG. The JTAG in this case was disabled, so it's a hardware disabled, meaning as soon as at some point, it's either a fuse or something that they've programmed in there that JTAG's no longer responsive. I can't communicate with it. The uart, however, worked. So I could read messages, but it wouldn't accept any of my input. The kernel's been told, hey, don't accept data from over the uart. So I was like, okay, well, those attacks don't work at this level. I'm going to have to move up a level. That's the process when it's booting, right? When it's booting, if I can get kind of into single user mode, if I can interrupt that kernel boot in any sort of way, then I can do some other things. It's still, even at boot, it wouldn't accept anything of my uart, and JTAG is just hardware disabled, so at no point was JTAG available to me. But if I could like get it to interrupt a command, then I could get it to go to safe mode, or it wouldn't do such a thing. Another attack at this level is called glitching. So on the device itself, the EEMC chip stores the Linux kernel, which is a separate chip from the processor. And what glitching is you take those data lines in between there and you pull them to ground. So when the kernel tries to read the root file system, it errors out. And you're hoping it's going to error out and give you some kind of like safe mode prompt, like, hey, I can't mount the root file system, what do you want me to do? For an IoT vendor, what you want to do, any IoT type device, if your file system is not where it's meant to be, or it doesn't find it, you want it to just fail and panic. You don't want it to try to give you backup options, right? It's not like your home PC where you're like, oh, let me just put in the backup drive. If your hardware's not how you physically built it, somebody's been mucking with it and you should fail hard. And that's what this vendor did. So if I glitched it, it would just say, nope, I'm not doing anything, it's not what I expect, and it panicked. And that's the right security response for a design like this. So I had to look further up. So understanding this firmware, this SoC chip, it's got a little bit of memory flash inside of it, and that little bit of flash isn't very big. It's not big enough to know how to mount an ext4 file system, and it's not big enough to load a Linux kernel into memory. So what it does is it's a little chip that will go read another chip, like a little flash chip, which runs uboot. And uboot is a little bit bigger. It knows enough to be able to mount an ext4 file system. So uboot's like the intermediary step. It will load up the ext4 file system. It will find the Linux kernel, load that into memory, and then pass execution to the Linux kernel. That's the uboot process. But when that runs, it's got some environment variables that it passes to the kernel, and by default, it's like a 3-second delay when it starts up. Like, it's got its own command prompt where you can interact with it or interact with the ext4 file system. In fact, uboot also supports TFTP. So like if it has an internet, I could go grab this kernel image from the internet and run that. So if I could get to that console, then I could pretty much own the kernel, and then I could pretty much own the device. However, that 3-second default prompt, they disabled it. There's environment settings that uboot has on its flash that tell it how to run, and they disabled that window I had to attack. So if you just set it to 0, then I don't have any chance to press a key and interrupt the process. That uboot typically resides on an external flash, and in this case, it resides on that little, well, that's so hard to see. On this flash chip right there. That's a little NOR flash chip on the backside. And it's just like an 8 meg chip that holds the uboot kernel. So I could try to replace that firmware image on that chip, and that's one possible attack. I'll come back to that. And then even before uboot starts, I mentioned there's a little tiny bit of flash built in the ARM system on a chip itself. That flash is very small, and all it knows how to do is go find this external flash and load up the uboot kernel and jump to it. You can attack it here, JTAG if that's available, or you can try to rewrite that flash. That one is like the most dangerous and least ideal option for an attack, because if you screw that up, you've just bricked the device, right? Like these others are lower stages, so you can have a second chance to catch them. But if I mess this up, I break the thing. So that's not an attack I wanted to do. Instead, I wanted to attack this uboot. And so what I'm going to do is I'm going to show you my toolkit for taking the data right off that chip. What I've got here is a Tigard board. I'm not trying to sell any product, but a dude developed this board just for hardware hacking. And what it does is it can act like a UART interface. It fuzz SPI bus. It can do JTAG. It can do lots of cool techniques. And so what I have is these little gator clips. It's an 8-pin gator clip. And all I have to do is take this 8-pin gator clip and clip it right on top of that sucker. And now I'm connected to it. And now let's see if I can get a window over here. Okay, desktop. Oh, I gotta close that. And then I just run as a command if I can find it. There we go. So basically I just say, hey, I've got this Tigger board out here. I want you to read the RAM off of this device and just drop it to flash.bin. Did that work? Reading flash. Boom, should be done. If I do an ls-lsa flash.bin, I can't see what I'm typing. Okay, it's there, and then let me open it in like a hex editor so we can kind of peek around at it. How am I doing at a time? Okay, good. Open file. Oh, where am I working at? I'm totally in the wrong spot, but oh well. Actually, I can't see that small, so I'm gonna do it on this other window and then move it over there. Let me steal this one too, see where I'm at. All right, I got this open now. The first little bit of this data is the actual U-boot kernel, so that's going to be ARM assembly code. We're just going to scroll past that. Actually, what I'm going to do is I'm going to do a find for a string. That looks interesting. There we go. So here you can see this big old blob on this device of environment variables for the U-boot kernel, and one of those in there right at the start is boot delay, and right now it's set to 1 because I've already broke this, but the first time I pulled that it said boot delay equals 0, and so all I needed to do is I change that one variable on this device and then reflash this chip. The next time it boots, it's going to give me that delay, and then I can interact with it. So that's all I did. I just changed this one byte in this hex image and then used my same tool to reflash that chip, and now I have a boot delay where I can interact with that device. So, bugger. I want to do that live with you guys now that I have the device. This window. So we'll flip this back over, and I'm going to hook these back up. Let's see, TX. If I get these wrong, I'll try again. All right, that's hooked up. And then I just need to I'll move this window over so you can see what I'm doing. Oh, you can't see what I'm doing because that's in the way. All right. And make that bigger so we can all see. And that should work. If I get the right device. And the right. Okay, so now I've got a UART USB device, and I've hooked it up to this solar panel controller. Now all I need to do is plug the solar panel controller in, and as long as my wires aren't touching, nobody's going to get hurt. Okay, that should start booting up, but I'm not seeing any data, so I guess I have my pins wrong. Oh, you see stuff? A little bit. It's trying. I don't think I have a common ground. Give me a second. Still not quite there. Try again, and I'll just reboot it. Yeah, it should be, oh, did I not have the right number? Yes. 115, oh, you're right. Missed a 0. Thank you. Okay, so now did I have the pins right the first time? Don't see anything yet. Oh, we were getting something for a second. Okay, good. Now, I'm still too slow, so we'll try it again. All right, so there it is. If I press a key, hold down keys, I should. What do we get? There we go. Oh, nope, not yet. So it's still booting. Okay, hitting the key. Oh, I didn't hit any key. I'm too lazy. It's too slow. Try that again. Oh, no, it's not too slow. I just forgot to hook up the TX line. Sorry, guys, it looks like a mess. This is actually how it goes for me all the time. This is hardware hacking. It works like 1/10 of the time. But when it works, that's all you need once, right? You only need to win once. Okay, device is booting. Okay, so there. Now I've got this U-boot access to this device. So with this, we're almost there yet. Thank you for the applause. It'll get better, I promise. So once I have U-boot access, I can now read the EMC chip, which has the ext4 file system on it. And so what I can do is, let's just go read the shadow file off that disk. So this command will say, go to that ext4 EMC chip and find the etc shadow file and copy it into memory address 9000 or whatever that big number is. I just chose something that I knew wouldn't corrupt any memory I need. And then all I can say is just, oh yeah, show me the contents of that memory. And so there now I know the root user's hash, right? Like, okay, now I can just go throw this at a cracking tool, crack that, and then I can SSH into the box. Unfortunately, I never was able to crack that hash. But it doesn't actually matter because I have a different way of getting in. Or at least I found a different way of getting in. So I never got in with this, but what I also could do is remember the firmware images that I couldn't get to before? There's the Encrypt tool on that ext4 file system. All I need to do is load that into memory, and then I just hex dump that tool, and then I can basically just XXD reverse, right? And then I got the Encrypt tool out of memory. So let's go back to my slides then and pick back up where we left off. So yeah, we pulled the flash. So here's basically what we talked about. I now have that Encrypt. I can just reverse the Encrypt and see, okay, how do you decrypt those images? And we see what I found is it has a hard-coded password, or rather, it does AES decryption. I was like, great, I just got to find the key. But I think they knew better than we shouldn't put an AES key hard-coded in the binary. So instead, what they did is this funky hash routine where they have these strings, these 5 blocks, and they hash them in different orders. They're like hash block 1, 2, 3, 4, and 3, 2, 1, 2, 3. Like they hash these, and then that hash is the password. So it's like we didn't hard code the key, we just hard coded how you come up with the key in the binary. It's like, you didn't really win anything. I still know your password, or I still know your key, and sure enough, with the key, I could then decrypt all the firmware images. Or, now that I have this tool, I can just run this tool and have it decrypt the images. Either way, I still have your firmware images. So this is slide like 1920 now, and that's where I typically want to be. I now have firmware access. I can read the firmware to look for other vulnerabilities. And so the fact that they encrypted their firmware and didn't provide them unencrypted, slowed me down 20 slides. So that's pretty good. Because as soon as I had the firmware images, I could go look at the web pages, and immediately, it took me like less than an hour having access to this, I found my first unsanitized user input on their website. This is a upgrade function, upgrade start, and you see here, it takes arguments that are passed from the user. So I could just argument, pipe, run a command, and it would execute it. So now, using that, I have command execution on the box. However, it's through this RCE, and I'd rather like to have like SSH access to the box. I'd like to have a full terminal, something easier to work with than this command line thing where I don't get to see, it's blind, right? I don't see the output of my commands. So I wanted the root user. So what I did, I couldn't crack that password. I just ran, changed the root user's password. So I changed the root user's password and then tried to SSH in, and I still failed. It still wouldn't let me in. It's like, I know I just changed that password. Why are you not letting me SSH into this box? So I started looking around the firmware and seeing what's going on, and I see that they have their custom PAM module installed. So if you're familiar with Linux, PAM is the authentication portion of Linux, and you can write your own modules to do your own authentication, and that's what they did. What they did is they hooked all authentication, even the SSH user authentication, and basically, if it's one of these type of methods, the password, verbose, or public, or mobile being the same method we saw before, then it runs its own routine, and you have to match its routine. So it didn't even matter what was in that etc shadow file. It's never even checked against that. That's why when I was changing the password, it never mattered. It has to match what this thing does. And this thing, all it does is it takes the username, and it says username at enphaseenergy.com, hashtag serial number, and that Enphase Energy string in funky case. It builds another string, computes an MD5 of that string, and that MD5 hash is your password. So this is weird to me because first off, this is really bad. This is not a good idea. The reason being is you cannot change your password, right? Like I tried changing my password and I cannot. The password is hard-coded because of this routine. And worst off is now that I know how it's generated, all I need is the serial number for a device, and I know every single password to that device. I know each of the different logins because they all use the same routine. And what this feels like to me is they knew, we can't just have one password for everything. We have to have a unique password for each device, right? One password's a bad idea. So like they knew they had a problem, but their solution actually made the problem worse. And that's like these 3 CVEs all came from that one module. Like you tried to fix one problem and you made 3. And this is, I don't know, I don't want to hash this too much, but hard-coded password can't be changed, and it's derived from the serial number and the username. So really all I need is the username, which I know, root, right? The serial number, that's the last piece. So how do I get the serial number? Well, it's on this board in 3 different spots there in red. That means you have to have physical access. That's no fun. It's also on the back of the case. It's on the bottom of the box, so it's right here. It's also right there. There's pictures online of like, even on their site, they have pictures, and the serial number is clearly visible for the device. If that's not good enough, it's on the inside of the service panel on your house. It's on the shipping box. So it's there. And then if you don't have physical access, it's also on this XML page. It's also on the home page, and it's in the title bar. Like if you couldn't find it, we made sure you could find it. It's everywhere. So with that, like if you do, so my model is a pretty lame one, but there are models that have cellular access, which means they're out there on the web, right? Like I can do a Sodan search and find these models out there, and I know their serial number just by going to this one site. So like I potentially could hack it and get in the box. So what should we do? Like, what's the threat? So what? You hack my solar panel controller. What you gonna do? Build like a DDoS out of it? Like, yeah, that's probably what script kiddies would do. One thing I noticed is that there's also this ability for the box to build a connection. And when you click this connect to Enphase support, the box makes a VPN tunnel into Enphase's network. And so they also have, I mean, it's a two-way tunnel, right? So you have a tunnel into their network, but that means they also have a tunnel into your home network, which was like, whoa, I don't think I like you having SSH access to my house. Thank you very much. So that was a big alert. I never actually seen how much access we have to their network. I didn't want to get in any legal trouble. This was a home project, so I wasn't being paid by them, so I wasn't going to step over any boundaries. But when I was looking at the box, something really caught my eye, and that is these things called solar renewable credits. So in some states, not Utah, you can sign up for credits, right? And then you get credits based on how much clean energy you produce. You can then sell these credits to corporations that have to meet a certain amount of clean energy quota, right? And this device is the thing that decides how much energy you create. So you see, in January, I really started to get in on this clean energy. I really was a big fan. 9,000 kilowatts of solar energy. And their system was just like, oh yeah, he's totally got 1,200 solar panels on his little roof. Yeah, that's good. But I was like, oh no, why stop there? Let's generate a whole bolt of lightning, right? Like, let's go to town. And sure enough, like, there was nothing stopping. Now, I didn't actually sign up for the credits, so I didn't get a buttload of credits. I didn't want to get in trouble. But I would hope there's some kind of sanity piece in there between the amount the user says they generate and how many credits you actually get. Because if that was possible, I mean, I don't even know what kind of acreage I'd need to generate that much power. Maybe somebody who's a little bit more solar aware than I am could tell me, yeah, you'd need like the whole state of Utah. I don't know. But that's a whole lot of power for my one little home solar unit to be producing. So, prologue, I found this vulnerability last September, about a year ago. I reached out to the vendor. Actually, I found it in August. I reached out in September. I told them, hey, I'm not after money, I'm not ransomware, I just have these vulnerabilities, I'm a hobbyist, and you've got these problems. And then the conversation is always a little awkward, right? Because they're like I'm always like, oh, I know people, right? I don't want to name names here, but I know people that are at this conference who have tried to reach out to a vendor when they found a vulnerability, and the vendor sits legal on them, and right, like cease and desist. And so when I do this, when I release this, I also say, oh, by the way, I've already told NIST. So go ahead and try to shut me down, but it's out there, right? I've got a third neutral party that knows about these bugs as well. So I told NIST, and I said, we typically, like, I'm not after money, I'm not after anything, please fix these bugs. I'm gonna talk about them in presentations in 6 months. So hopefully you can fix them by then. That's all that we're gonna go with this. It took a little while to get the right contact on their site, right? Like all their site had was like the tech support, and the tech support was like, who the heck are you? But I got to the right guy. They said, thank you very much. We'll get these fixed. And then in January, I just sent them a follow-up, said, hey, RSA is like 3 months away. I'm going to talk about these. Are you going to fix this? And they're like, oh yeah, we'll have them fixed by May. We're going to release a fix in April. Then in April, I sent them another email like, hey, I'm going to talk about these next month. I didn't hear back. And then in May, I was like, okay, I'm talking about them tomorrow. I still haven't heard back. Like, they just went cold on me. I was like, fine, like, I'm going to bring these public. I've been watching that AWS repo. There has been updates to it, but none of them have addressed my bugs. However, they did add this additional web page, and they turned IP tables on the device. So the SSH port isn't accessible to you on your home network anymore. It's only accessible to them on that VPN tunnel if they build that. However, there's this web page that's called what is it? What is the web page URL? I forget what it's called. It's something like services IP tables. And this code is what it does, and basically this code checks how long the machine's been on, and if the machine's been on less than 5 minutes and you hit this URL, it turns off IP tables for you. So they put the security measure in, and then they backdoored it. And it's like, well, okay, I can reboot the device. That's easy for me to do remotely, right? Like, I have login creds to the web panel. I just reboot the device, and then I can SSH into the box. So their fix, like, they still don't understand this security thing. I don't know how to help them, especially if they don't want to talk to me about it. So I checked last week. I plugged this device in, hooked it to the internet, hoped there was like a firmware update. There is no firmware update. So you guys that have these at home, I've got a blog. If you want to come reach to me afterward, I can tell you what you need to do. I can give you a script. If you want to like SSH into your home box and just kind of peek around, it's yours, right? You can do what you want with it. But I wouldn't recommend you break it, because it is a profit point for you guys, right? But in overall, I feel like these guys broke the one rule for crypto, and that's never roll your own crypto, right? Like, oh, we've got this password problem. I know I'm going to come up with my own solution. If you guys are developing something, you're probably not the first ones to have that problem, right? Like, look around, see what other people have done. Yeah, it's a bad idea to have one password for everything, but it's an even worse idea to hard code a password that nobody can change. If you have this device at home, you can't change your password to fix this. You have to like manage it with firewalls, because the device itself is fighting you. It won't let you secure it, and which is really disappointing. I think I've actually got a little bit of time. I ran faster than I thought it would, despite all my troubles. Do you guys have questions or comments or things you want to discuss? I'd be more than happy to talk about them. If you want to talk about it private, you can too. Yes. Wow. Okay, it's not as much as I thought it would take. 3.4 acres, guys. Let's go out to Farmington. We can make that work. All right. In 1 year. Oh, in 1 year. That's the catch, right? Like, I just did mine. I was doing that continuously. Like,
15 square miles for that.
Thank you. 15 square miles of solar panels. That's a lot of solar panels and infrastructure to manage it. Thank you. Any other questions or comments? All right. Oh, there was one. Yes. So, and I guess I didn't make that very clear. His point was, can't people use this to launder money? Yes. That is a huge vulnerability in my book, right? Like, worse than all the others. The fact that this can be used to launder money, I think it can. I haven't actually tested it, but it appears to be set up that people can launder money. I agree. I would think that they would be very concerned about that. The code that they use to report how much power consumption you do back to their site, it does some funky, again, hand-rolled encryption. So I think they understand that data is very important and it's very critical, but I don't know why they didn't feel like this was a big issue. I really think that they've kind of got the same mentality of, let's just brush it under the rug. Nobody's going to know. Nobody's going to care. I don't think, it feels to me like this is a very young and naive company and doesn't realize how security works, or how the security industry, how to interface or work with the security industry. I don't think they've matured to that point. That's my personal feeling on the comms I've had. But yes, that's a very bad point on their side. Okay, cool. Well, thank you guys very much. If you got personal questions, come on up. I appreciate you listening for the whole thing. So thank you for humoring me.